Alright, we're up. Oh, nice. So we have new announcement from Veronica and Mohammed, our TAs for the semester. But yeah, you guys can read announcements. I won't read it to you, but we're active in our, let's switch over to student preview. Things moving a little slow. So main things for this week that we're working on is try the first quiz, and well, also, sorry, I skipped one. I don't know why I skipped it. Let's go in order. Discussion board. So make a GitHub account, make a post on the discussion board. That one, at this point, you probably have like 6,000 accounts online, so you're probably pretty good at making accounts. Then quiz 0, we could take a look at that one first, and then we'll try to make like NanoHub accounts so that you have access to like launching Jupyter notebooks. And that way, when we get to module 2, you're like ready to rock. Launch it up, start doing some Python stuff, looking at some graphs, pondering. Sound like a plan for today? Straight into it. Are there still lingering issues from Friday? We went deep on Friday as to like, what is the meaning of life? Do you have free will? And was there anything, because now I'm like jumping into specific assignments. You're like, but I just came to terms with my own like morality and ethics code. Yeah. All right, you can always stop us. If you're like, how does this connect back to? So again, like kind of general format is like the folder has both the stuff that you're supposed to do and then a place to put things for your work. So we'll pop open quiz 0. Most of the quizzes you'll do like on your own, just like we'll build them together in class, but this one I wanted to show like at least how I would go about it. Everything's moving like slow today, at least on my computer. I feel like I'm moving fast. So I have Spider-Man, and it's asking you to draw a free body diagram and then write down Newton's second law. I overheard some people talking about like, how do you draw, like, what's with that guy? What am I supposed to do with that guy there? So I can show you, actually, rather than showing you, what did you do with the guy? So let's say this is my Spider-Man. And I'm just going to do a point mass. So I have tension from my web. I have weight of Spider-Man. What did you do with that bad guy? I didn't expect you to like have it done already. Like it's not even due yet, but if you were already thinking about like the fact that Spider-Man is carrying someone, what did you do with that force? Was there a force, or is it just sort of like something's happening, right?
I was thinking, I didn't do it, but I was thinking about it. So he definitely counts as an additional weight force.
Okay.
In addition to Spider-Man, so you can interpret it as like a weight force on the side, or if you want, you could just consider them both as the free body and move the center of mass.
So we could say like weight plus weight, something like that, right? Like there are two weights acting. acting on Spider-Man. Okay. And sorry, there was also one other hand. Similar idea. And so another thing that we could do is say, like, Spider-Man is kind of pulling on the bad guy, right? So there's got to be some kind of like force, or let's do like an R, like an internal, some kind of internal reaction force saying like bad guy plus Spider-Man are connected somehow. I don't know what, maybe it has two components to it, maybe it has one component, but that's another way is I could like say, if I want to combine them all into one lump mass, that's fine, but it's one approximation. And yeah, we're engineers. We got it. Sooner or later, you have to approximate something. You can't like model the entire universe every time you want to sharpen your pencil. We gotta start somewhere. Okay, so that's kind of like number one of many interpretations. I don't know if you want to do like if you're working like a full 3D rigid body analysis. Yeah.
You just explain why it's R force, like a normal reactive force?
So like if I look at the bad guy, kind of looking at the two free body diagrams together, there's like Spider-Man moving and bad guy moving. Bad guy has no webs connected to him. Like he's not swinging at all. But Spider-Man is holding bad guy, so somehow there's internal equal opposite forces between Spider-Man to bad guy and bad guy to Spider-Man. So based on the way that I drew it, really I would probably flip the arrows now that I'm thinking about it more. Just so that it's like there's a positive R bad guy rather than a negative internal force. Just after I drew it. That would be my thought. Yeah. Yeah, because if Spider-Man wasn't there, it's just bad guy falling. It's a free fall bad guy problem. Bad day for bad guy. And then number two, Newton's second law. We already wrote that, depending on how close to the original, like Newton, we could say like F is the change in momentum, ddt of mv, or d dt of p, or p is momentum, however you want to write, or you could write it out kind of in words. So I've got my stuff. First thing is like a PDF of your work. Next part is like 10 to 30 seconds talking about like how you did this quiz. So it can be an audio file or a video file. Either one is fine. I'll show you like how I would record this like short video to say like, yes, I understand, no, I don't understand, something like that. Ready? Okay. 3, 2. So this is my quiz 0 submission. I drew forces on Spider-Man that I know are there, like the force from the web is some kind of tension, the weight of Spider-Man. Then I know there's some kind of connection between that bad guy that he's holding and him. I wasn't sure how to draw it, so I drew another free body diagram of the bad guy, some kind of internal force that I'm not sure how to deal with yet. And then for number 2, I am sure of that. Force equals ma, but I wrote it out as force is a change in momentum. Cut. So there, like 15, maybe that was 20 seconds. I talk a lot, I'm a professor. But it's just something where you're thinking about like, where did I get this answer? If there are things that are unclear, just point them out. Like I'm not exactly sure where this is, and it helps if TAs are kind of looking at it, thinking about like, where did this come from? it gives them a little bit more info about where, if you need help, what you need help on, those kind of things. Yeah.
Are you hard pressed? Are you hard pressed for it to be a video or audio file, or can you just write a paragraph?
It does have to be like video or audio, yeah, rather than like handwritten. You can like write something out, but then just like record yourself saying it somehow. It is like here we're all like in class together and doing a lot of work together, but a lot of times these assignments are kind of like online, like remote submissions, and this is the best way that I've found of like doing a remote exam. Here it's a quiz. It's meant to be like 20 minutes. Like all the quizzes should take about this long. At least if you're like coming in like, I know exactly what I'm gonna do, then it's pretty quick. So this is my way of like saying to the university, like, yes, I know that the person who submitted this is the person that they say they are. So it gives you a little bit, and reflection is like, that's the key to education. If you take even just 30 seconds to think about like, what did I learn versus what did I not know, you're gonna accelerate like how fast you can think about and study problems. So I'm forcing you to do that.
If we've already made a submission, can we make another one with like updated?
Oh yeah, definitely. And that goes even for all the quizzes. Like if you submit something and then a week later you're like, oh my god, I forgot to record some like an audio or video file, then totally just add it on there and resubmit.
Yeah. And just to be clear, do you want like our submission to be like a PDF and an audio file, or can it like be a direct picture?
So this one, I guess you probably could PNG or any kind of pictures, PNG, JPEG. They usually show up pretty well, and you can mark it up. PDF is usually the easiest one, like smallest files that are easiest to like view. As long as you're using like normal 8.5 by 11 sized PDF kind of paper sheets. Sometimes it gets weird if you're like building PDFs of posters and then submitting those. But yeah, PDF is our main, the portable document format. Does tend to be pretty portable, even though it's not very friendly. Portable but not friendly. It's just hard for computers to interpret PDFs most of the time. Cool. Yeah. That one, yeah, because all it's asking for is write out Newton's second law. Write down Newton's second law of motion as an equation. Yeah. So you can put any form of F equals ma that you want to put in there. Oh, I see what you mean. Like, should we be saying the sum of the forces on Spider-Man is the mass times acceleration of Spider-Man? Yeah. I mean, you could do that of like here F equals ma, and here are all my forces. So let me add those all up into one big F, and then here's one big old Spider-Man A. Something like that. So here, mostly I just wanted like give you practice of like write an equation. And that's an equation that most people coming to the class are like pretty familiar with. But if you wanted to try like write that equation and try adding those forces all into the F term, that's up to you. But all you're asked for is Newton's just a general, what is Newton's second law? Yeah. I don't know if that answered your question or added more questions. Oh, some in each direction. Yeah. In this case, really, what I would do is if I was going to say these are all equal to sum of the forces, I would say that it's equal to like a MA radial and like MA theta, like use some cylindrical or spherical coordinates on there because it's like a rotating problem. So you end up doing a lot of the trig in the definition for acceleration rather than getting all the components into the right places. But you don't have to, because F equals MA no matter what coordinate system we're in. Yeah. Yeah, thanks. Okay. Let's try today. It's going to be like more setting up like NanoHub, trying to get into the system. Oh wait, what happened there? Oh, there we go. There. Okay. I don't know why it brought me to a different. So I'm gonna open this up into like incognito window, so I'm not logged in. And then it brings me to like our main. So this is the same course website. It's the only difference is now everything is a Jupyter notebook. So once you're logged in and you have access, now you can like edit the notebooks. You can make notes in them. You can change them around. So if I try to click launch tool, it's going to tell me like, hey, you got to sign in somehow. Don't use institutional credentials. It just doesn't work. So don't do that. Don't do that. I think Google does work pretty well. Like if you do want to sign in with a personal Gmail account, that one is one way to do it. Or create an account. So if we create an account, my username, password, first name, and then email, this one. That one, you can use your Yukon email, like there's no issue with it. If you want, you can fill in the rest of the information. That's funny, Facebook profile. Do you have Facebook accounts? You do? Oh, really? I thought it was becoming like a mom thing, like only like older people use Facebook. Not to say like you should get rid of your face. It's just that was the feeling that I was getting anytime I had logged into Facebook recently. It's like it doesn't feel like a college thing anymore. I guess so that you can use Facebook Marketplace is the main thing. Yeah, Craigslist. That one's the real like, oh man, the MySpace of online shopping.
Does our username need to like match our real names?
No, it can be any. So there's no direct connection. So however you log into this, it's all your own account. Like Husky CT is not going through NanoHub at all. There's no direct connection. So it's all sort of like spider web, not interconnected. Well, not spider web then. Hub and spoke sort of thing. Things go out, but they're not cross-connected. All right, so then once you have password, and email, it might, once you like create an account, it might bring you to the main like NanoHub page, which this page is just has like everything, and you're not gonna find like our specific resource on there because there's, well, I guess this one's called a tool if I want to use like the vocab from NanoHub. You're not going to be on our tool page because there are over 500 tools all offered through NanoHub. There's tons of awesome like stuff that you can use on here. Like if you're into chemistry and stuff, there's like density functional theory and molecular dynamic models and electrical engineering sort of stuff. All sorts of like good, cool material science stuff. But we're going to, you can always go back to the website and then say, all right, well, now that I'm logged in, let me launch that Jupyter Hub, and it'll bring you right back to our tool. Then I'll launch this, and then I'll check in and see what people are up to at this point as it loads up. How's it going? Were you able, you were done? Okay, cool. No issues. Okay. Good. All right. Yeah, you're
It'll take a while to it sounds a little bit
yeah, so once you're in there, it'll have a list of like all the notes.
Do we click launch?
Yes.
Oh, so like if your Wi-Fi is a little wacky in here, but if you see the PWE 150, you can log in with like Yukon 123. If Yukon Secure is not working, today it seemed to be working okay for me, but anyway. Yeah, it's like you're doing everything right, but the internet is just not cooperating.
You know, only Newton didn't invent that.
Okay.
Now you need to go back to the page.
I guess click yes because there's only one.
And then
I guess click yes. I guess link, right? Because you just said we're going to use. I don't want to link.
try signing in by like Google.
What was the discussion?
So create a new model. Is this nano called or are they just, I don't know what's happening. Show us your favorite equation related to it.
Yeah. Yeah, now you're getting fancy. So, when I launched it, I went to the Dragon's Energy, but I said no because I never logged in before. Yeah. It said this existing account already used. Okay. And you can click. I did. But then if I go back, yeah. I can log out. Yeah, but I didn't use that as a reason. Because it's just saying my account is invalid. So if I go and log in, yeah,
You are logged in.
wait, but now it's a different name. So I'm a little confused. So then what happened is you just try to launch it. Yeah. This is. Oh wait, but this is. Oh, maybe you need to like say yes. This.
Yeah. I got one of those.
Okay. You need like a certain delay so I can get to the middle. How's the middle of the class doing? All I can get to is the edges. Good. How'd it go? Oh, you're in. All right. Yeah, so perfect. Okay. But it's still just like
Wow, you're really like investigating. I didn't know my work was this organized.
Everyone's so safe.
I don't think we
Oh, like the fire. Oh, okay. Oh, wait, that's the actual. Yeah. Really? How long were you there? Then I was there for 2 weeks.
5 minutes. Oh wait,
5 minutes ago was criminal.
over 30 project.
But it was nice because they yeah, it's or like just like oh, okay.
Minimal technical skills. Copy and paste. Create graphics. Working out the buddy.
Yeah.
Okay. Good job, buddy.
I'm sure there has to be a way to like delete cap.
Change it.
Nah, that's cool.
Usernames aren't that relevant anyway. I'm named after. I made this account when I was 12.
Why did I just get this whole random
Pokemon. He's the best Pokemon. Oh, don't even start. He's my
Yeah, and I tried this days after. I don't
giant. He's a new giant ninja bug. Look at him. I have
one week
this is my favorite card that I own.
Oh, I'm stupid.
What's the one that just looks like
There's a lot.
I know, no. It's a robot.
Onyx? I know literally every
They're robots. They're robots. I said if I looked it up, it will come up.
Is it Goler? Oh, Regirock? Is it Regirock?
It's like these. There's a bunch of these.
Yeah, the Reggies. No, look, this is Regirock. He makes like the noises. And these are like the guys.
Yeah, those
Reggie, Regirock, Reggie Steel, Reggie Day. There's others now. You get Reggie, Alexi, Reggie Draker. Regirock is the most goated Reggie. They're just chill guys.
Alright, we came up with some issues, but it looks like we do have a quorum onto NanoHub. Oh, there we go. Let's do some fancy. All right, so I'll show like my screen so you can see one way. Like if you use the arrow keys, then it'll navigate like through. So you can do like arrow up, arrow down. This is called kind of the general Jupyter layout is like this is called a cell. So right now it's a markdown cell, so it's got like information in it, some kind of like writing. And this is called, so it'll catch up with us in a second. This is called a code cell, where now it's like actual Python code. So if I hold shift, hit enter, so shift enter, it's gonna run that cell, move on to the next one. Yeah.
How did you get to that page?
This page?
Yes.
So when you load up, when you say like, okay, get me into that NanoHub,
Yes.
like engineering dynamics. Yeah, so on that comic page. we're in module 0, getting started. That's like our first homework 0 assignment.
Well, getting started with Python.
Yeah. So then we've got, when you go through the notebook, one way to kind of get through it, this is both a feature and when you're using it, it feels like a bug. Like usually it's written so that you go from top to bottom, like execute one cell at a time, and whatever you define up top, you can use it down at the bottom. But if you go to the bottom, run something without running the top, then it tells you like, hey, that variable doesn't exist, or hey, this doesn't exist. So it'll feel like it's broken, even though that is, technically it's a feature, so that you can sort of like debug along the way, restart, see what you need. But so one way to get through the notebook is hold shift and just keep hitting enter. My screen key is like just not working anymore, so I'll get rid of it. So we'll get down to our first like Python code that we're using, just doing like calculator stuff. So we can run stuff, it'll think about it. If it has a little asterisk, that means that it sent the command and it's waiting for some kind of response. Yeah.
How are you running the cells?
Right now I'm holding shift and hitting enter. Another way that you can do it is click on this triangle, like the play button that says run. So if you click on that, it'll run each cell. So I could say like, oh, I moved. So I could keep clicking on run and get through each of these calculations. Do you know what that double slash does? So 7/2, 7 divided by 2. But what is 7//2? Yeah. Like a floor division? Yeah, yeah. So it just gives you, like if you were doing long division, it just gives you the part before you get to the remainder.
Before we start editing, do we make a copy of this, or?
Oh, you don't have to make a copy because like this is your own version. So any edits that you make they'll be saved like in your own account. So if you like atomic bomb and just like delete everything and then you save it, you're like, oh wait, I didn't want to do that. Like what happened to all the code? Like we still have tons of copies of it everywhere, so we can still like get the original back and start from scratch. So we can go over to GitHub and like download it, put it back up in there. That's okay. So there's like floor division. Do you know what the % does? The remainder, yeah. So floor division plus the remainder, that gives you like that improper fraction. So we could say well, we could say this if I actually didn't run into. So we can do like 7 over 2 is 3 remainder 1. Is that right? Yeah, 3 remainder 1. Yeah, that's good. Yeah.
Is there a way to add that like output box without just taking like for some of the later levels?
Add
The output to automatically pop out.
oh, like right here.
Yeah.
So by default, so like right now, actually, yeah, we'll do this. So if I do like 2 calculations and I'm not telling Python like, hey, do something with that calculation, then the only thing that gets outputted is whatever I did last. Print statements will always print out because you're telling Python like print out whatever I tell you to, like do it. But if you just tell Python to like do something, then the only time it shows you what it did is if it's the last line in your cell. So if I'm trying to like print each thing that I'm doing, then I would have to say like, all right, well, print this, and then print that. And now it would show me like the result of each of those. And other option is we can edit and split the cell so that there's only one line for what you did. So if I click on that edit and split, now I'm back to like each cell does a calculation, shows me an output. Something like that. Yeah.
Is that how you make a new cell? You just have to split one of them, or is there another like new cell button?
There's also new cell. So if you click insert, you can either put one above or one below, wherever your blue, whatever's highlighted. That's where. So I can put one right there if I click above, or right below the screen if I click below. So say above. And then I've got new cell. I can start working. Green means I'm editing. Blue means I'm kind of selected. So right now I'm in green, edit mode, hit escape. Now I'm back into like edit mode. I could say like, all right, we'll move this thing up here, or move the cells around. Got all sorts of like fun editing and stuff. That one's going to give me an error. That variable does not exist, not defined. No function, no variable. So we'll delete it. Let's go down. Yep. So what's with this 9 to the 1/2? Square root of 9 is 3, right? Why is 9 to the 1/2 4.5? Yeah.
It's doing 9 times the 1 divided by 2, or 9 to the first power divided by 2.
Yeah, so 9 to the 1, then divide by 2. Even though, like, if I were to write that on a piece of paper, I would know order of operations is that do the division inside that thing. But you have to be pretty explicit with, and you probably, like if you use graphing calculators and other programming languages, you probably run into that. and spent an hour like yelling at a screen, like, why won't you do what I tell you to do? And then finally you're like, oh, I forgot to open a parentheses in the right place. Just some quick gotchas. And variables to type. Let's jump down. So let's do, how much? Oh, we only have a couple of minutes. So we'll take a look at this. Do some kinematic equations. What is this equate? So I have like these two x and y. What is that? What am I doing here? Like, what am I looking at? Yeah.
Projectile motion.
Projectile motion. Okay. So what is x in my projectile motion? Yeah.
Position along the x-axis.
Along an x-axis. So what's different between the x-axis and y-axis? Like, why am I calling it x and y? Well, yeah, we'll just jump back and forth. Yeah.
It's different between the x and the y because there's no acceleration in the x-axis, but there's a downward acceleration in the y.
All right. So along this x-axis, there's no acceleration. That's why it's just whatever this Vx number is, that's a constant speed. It's not going to change. So this is describing, like, for a constant speed, this is how far I will move along that dimension, whatever like that scalar value of x position happens to be. For projectile motion, usually we consider that like forward, like some kind of forward motion, right? Okay. And then this equation is different, right? Why is that one different? Gravity, okay. So that's why we have like a g here. And g, we can kind of scroll back up, kind of fill in the blanks. G is that gravitational constant. So now I have like, there's some initial Vy, but it's changing. So at each point in time, Vy is always losing 9.81 meters per second every second. Even if it starts up, goes down, cool. What about this? I'm using t, and I'm saying t is this. So what are we doing here? Yeah.
It's giving you an x and a y value for each of those values.
Okay.
So t is those 6 points and then plugging those into those equations.
Okay. So I'm going to have like 6 different values of x and y because I have 6 different values of time. And that's how we can think about, in general, usually what happens is like time is our independent axis. Like we say, I want to know what happens at 10 seconds. So let me go from 0 to 10 and figure out what happens along the way. And that's what we're doing here. Time gets defined, and then we calculate what is x and y based on those points in time. So we can do that and then say, hey, look, it goes up, then it comes down. And plot x and y. This is called the path when you look at x and y positions. All right. Thanks a lot. Next time we'll jump back into here. If there are still issues, let me know about like getting into NanoHub or using Jupyter. Take a look at this and then work on the problems that are at the end.
So this